Hi, my name is Norm, and in this demo, we're going to be talking about the RF workflow when working with NI vector signal transceivers, or basically one or even a system as complicated as what we have here. And when I mean workflows, I mean what do you do when you walk up to instrumentation that you might already be familiar with? Well, you might want to look at a spectrum, you might want to generate some tones, look at the things together, basically ring out the functionality. And what we should be able to do with, once again, a complex system or a simple system that basically only has one analyzer generator or a transceiver in it, is just get up and going and start doing those types of operations. So what would we do? What is that behavior? What's that action? What's that first step in the workflow? That first step in the workflow is to open up InstrumentStudio. That is, whether it's on your desktop as a big honking icon or in your start menu, or maybe it starts up automatically on your system, you should be able to launch InstrumentStudio and then be presented with basically all the instrumentation that is kind of enabled within InstrumentStudio as an ecosystem, not just RF, from a unified interface. Now, if you had a simple setup, you might go ahead and do an auto-create layout. Maybe you had a few instruments, power supply, a DMM, and a VST, let's say. We clearly have a lot more going on in here, so we're going to do a manual layout. And so, much like most traditional instrumentation, most traditional instrumentation nowadays, when it starts up, it auto launches an application that gives you just sole interface to that one instrument. What's part of the power of InstrumentStudio is that not only is it a unified or an interface, like a no-code interface to your instrumentation, but it also is the no-code interface to all the instrumentation. So you should be able to see here, I've got basically all the things that I maybe had mentioned earlier when I was talking about, hey, we've got multiple vector signal transceivers. We have vector signal analyzers, vector network analyzers. So a lot of different things in the system as a whole. So the first thing that we might look at here is we're going to go ahead and assign that analyzer to a large panel. And you can see as I click on that and assign it, it moves it over there. So it's not a drag and drop interface, but it's really about the same. And then we're going to go ahead and assign that signal generator over into that small panel. And so now you can see as I zoom out here, now we have both of them visible within that interface. And when we go ahead and click OK, it's going to go ahead and initialize this instrumentation. Now, once this instrumentation is kind of kick-started and operational, this is the first time it's starting up for the day. So you can see as this instrumentation starts up, now we have access to the analyzer and generator. And through our switch matrix here, we have it, or the switch network, we have it set up in a loopback configuration. Now, we're not really seeing anything happen, but just because our generator, as any good generator does, doesn't start spewing out RF power the minute you turn it on. So the first thing that we'll do is we're going to go ahead and simplify the display. We're going to go ahead and get rid of the project view. We're going to set our signal generator. It's currently set to 6.5 gigahertz. We're going to go ahead and change that level from, say, -174. We're going to go ahead and bring that up to something, say, -20 dBm. We're going to go ahead and turn that RF output on. Now, one of the things that you might notice is we're not seeing anything on the analyzer. If you've been paying attention or if you've navigated or kind of seen what we're looking at here, you'll see that some of the typical things that you would program on a spectrum analyzer are all available here in this section. So center frequency, span, RBW, reference level. So what we're going to do is change that to 6.5 gigahertz. So all I need to do is hit 6.5 G on the keyboard. And you can see it's already tuned to that signal. And so now we're looking at that overall signal, effectively ringing out the path that we have within the system. Now there's a variety of losses that we have because, switch matrix and splitters and couplers, oh my, all the things that are in between. But this really is that first step towards getting operational with just a generator to generate a simple tone and to go ahead and look at the spectrum of whatever signal that you're looking at. Hopefully it felt pretty familiar. So one other thing that is important about this interface is that it is it's a configurable collection of instrumentation, not just a discrete instrument, something I mentioned a little while ago. Now, how would you, what does that mean to you as a test engineer or somebody using this, or somebody who even is maybe a test manager and has a lab full of individuals kind of operating on the same type of devices? Well, the reason that this ends up being relevant is because it is a configuration-based, kind of a data-centric configuration. And one of the things that you'll note is over here on the left is that it starts to build up this tree of different instrument configurations and different display views. Now, this is one instrument that we're looking at within the chassis here, where it's just basically looking at an analyzer and a generator. And what we're going to do is we're actually going to open up a new tab, which is basically going to be a new instrument within our project that can be saved off to disk and loaded up at a later point in time, drastically accelerating your time to go ahead and get up and running at a given station, or get somebody who might not even be familiar with your current station setup operational, pre-configured to say your frequencies, signals, personalities, standards, and things of that nature. So one of the things that I'll do here is I will go ahead and create a new tab. I'm going to go ahead and create actually access to our latest and greatest network analyzer. So we now have a PXI VNA that is accessible through InstrumentStudio. So once I go ahead and select that, I will create a new network analyzer. It will attach to the one that's in my system, giving me the ability to, once again, not only take wideband analysis and generation, or wideband generation and wideband analysis, but also the ability now to go ahead and look and do network analysis, giving you your viswar of your ports or your full 2-port S parameters. Now, we're not really seeing anything all that drastic here, but that's really not what we're trying to highlight within this demo. I wanted to show you those basic workflows. So, but I will go ahead and configure this just to kind of showcase what we're about to do. I'm going to go ahead and configure it. I'm going to save it, close it, and reopen it, just so that you see that common workflow that can really get you or your team up and running a lot faster. So I should be able to put this to say 100 megahertz, 26.5 gigahertz, and say 1,001 points. And you can already see that we're kind of interactively controlling our network analyzer as you might want. Now, both of these are saved over in the project view over here to the left. I'm going to go ahead and give each one a unique name. So I'm going to say VNA component test. And I'm going to go ahead and actually switch the component in, set it to S21. There we go, and we can see that we have some of the performance of that VNA, or of the bandpass filter that we have in there. You know, it's uncalibrated at the moment, but you can kind of get the idea. So we're going to go ahead and save that component test for those frequencies. And I'm also going to go ahead and save that project. I'm going to say just basically demo workflow RF VST VNA. So that's the name of my project. And now I'm going to start to save those individual tabs to go along with it. So for my instrument, I'm just going to do VSA VSG loopback. Oh, can't put a slash in there. That's my fault. Let's say VSA VSG loopback, because each one of those will actually be a file saved on disk. So it makes sense why a slash within that name is unacceptable. All right, so now I've got them both saved there. I'm going to save all components of this, and I'm just going to go ahead and kind of show you that last bit of the workflow where we close it down and we open it back up to that very specific workflow, and then you're back up and operational. So it should be a big time saver. Also, once again, hopefully it feels familiar in terms of, hey, I don't have maybe my traditional old school knobs and buttons, but I have the ability to get up and running very quickly. So in order to illustrate that, we're going to go ahead and open up InstrumentStudio. It should launch, and then once we get this, we are going to go and look to the recent files, because it's going to basically launch with nothing active. So you see that we've got InstrumentStudio now open. It's kind of back to that default interface. And you can see over on the right-hand side here that we do indeed have some of the recent ones already linked, or we have the ability to go up to File and then open a recent project. And so we're going to do that demo workflow that we had open just a moment ago. And you'll see that very quickly we will be already configured with both the vector signal analyzer, or SpecAn, and our signal generator, and our vector network analyzer pre-configured to the exact same settings that we left it last time. Let's go ahead and simplify our view. Let's go ahead and run the vector signal generator, and now you can see our signal coming through. We can even collapse that right rail to get more screen real estate to kind of see a bigger view of our spectrum. And of course, we can go over to our VNA, and once it goes ahead and associates with that instrument the first time, we have the ability now to go ahead and look at those network analysis capability, or basically the behavior. Actually, let's even just go ahead and auto scale one time on that graph. We can kind of now see the full spectrum associated with that instrument. And one last thing that's kind of nice, especially when you've got a complex system like what we have here. Let's go ahead and close out our VNA. We can go ahead and save. That way it'll save the axis configuration as well. One other thing that's particularly nice is that if you have multiples of a thing in a chassis, you also have the ability to go ahead and relink, or basically take all the settings that you have from one instrument and transfer it over to the next one, simply by going through the process of basically going to the configuration gear over here, going to the device that you have, going to relink, and then choosing the other device that you have in the system. That, of course, would match with the current settings, which is basically what we've got here. It's going to go through, and you can see we now have a new name up top, and of course, our tone is no longer operational. So let's go ahead and do that same operation with the other generator. We should be able to go here, channel 1, relink, and now you can see that we're back in operational, transferred both the analyzer and generator settings to an entirely different piece of hardware within the system. Also, that file is transferable to other computers as well that might have a similar setup. So once again, it now becomes a reusable workflow accelerator for you, your team, your lab, for your program. And so hopefully that gives you an idea of what it's like kind of just getting started working with some of the basics of a vector signal transceiver, be it for signal generation or analysis, or even now network analysis within the NI PXI system. Thanks.